Today we'll discuss the idea of momentum, which is a kind of a natural extension from the three laws. We have done with studying the three laws, and then we come to this new concept of momentum. So I'll tell you where the idea of momentum most struck me. Okay, and this was when I saw a video which is there on YouTube. I'm sure if you search for it, you will find it, but you'll also find a lot of trash, so be a little careful. And this was a collision between somewhere in Southeast Asia between a guy on a scooter, an old man on a scooter, crossing a railway track, and a train approaching the railway track at the same time. Okay, so what happened was this guy was on the scooter. He was crossing a level crossing, as we call it in India, an unmanned crossing. And in that, while crossing the track, he didn't notice that there was a train heading towards him from one direction. Now, the train had slowed down considerably because it was approaching an unmanned uh, railway crossing. And I'm just putting a number to it. I'm saying it was moving so slow, it could have been about 1 meter per second. Okay. The man, just before the crashing into the train, notices the train. So he almost comes to a complete stop in order to try and turn around. Okay. So his velocity was almost down to zero. The surprising thing was when the train struck the scooter, the amount of acceleration that the scooter had threw the scooter to the side. I think it hit one of the side posts, and of course the guy then got up. The guy also fell down. Then he got up and he moved away. It looked like he had not been injured in the accident. So that way it was fine. He got away alive. But what got me thinking was that how come two objects, one of which is at almost at zero velocity, another moving as slow as 1 meter per second, when they collided, it produces such an enormous amount of acceleration. So the force would have also been great. And I kind of compared it to the situation, what if it were another scooter colliding into this person? So if it was just two scooters, so to say, colliding into one another, so one is coming from this direction, and there's a guy on this, and these two scooters are going to collide into one another, and this one is moving also at the speed of 1 meter per second. You can immediately see that the damage would not have obviously been much larger in the collision between these two objects, whereas in this case the damage was pretty high for the old man on the scooter. So that brings us to the concept of momentum. What is the difference between this object's motion, the train's motion, and the motion of another man on a scooter, on a similar kind of a scooter? So the difference is the quantity called momentum. Yes, does somebody want to ask something? No? Okay. So I introduced the concept of momentum, the difference between these two things as the difference between the momentum of the two objects. Momentum is defined, it's usually given the symbol P. Okay? So classically, the symbol for momentum is P. That is given as the mass of the object multiplied by the velocity with which it is moving. And you can see that the difference in these two situations is that the mass of the train is enormous in comparison to the mass of the man on the scooter. Okay, though both of them are moving at the same velocity. So the mass of the train, which is probably several thousands of kilograms. Okay, so it's an engine. Let's say it was just the engine. The engine by itself will weigh anything up to 40,000 kilograms, maybe more, but I'm just taking a rough estimate. Whereas the mass of the guy and the scooter, maybe 60 kilograms for the guy, another 40 kilograms for the scooter, say it's about 100 kilograms. Okay, so if you want to compare the momentum now, so the momentum of the train will be equal to 40,000 kilograms multiplied by the velocity 1 meter per second, whereas the momentum of the scooter will be 100 multiplied by the velocity 1. So naturally the momentum of the train is going to be 4,000 times the momentum of the scooter. But it still remains to be seen Why does the force therefore of the impact between the train and the scooter is far greater than the force of impact? We haven't connected that idea. What we can see therefore is the momentum of this train system is much greater, 4,000 times greater than the momentum of the scooter system.
Sir,
So maybe that is the clue to understanding why the forces were much greater. Yeah, Rohan, your question.
yeah, sir. So how do you say that, like, the train's momentum is so 40,000 watt? What?
Exactly. Thank you. Thank you for asking that question. So that brings us to the next point, which is how do you measure momentum? Okay. Units of P. And I think you can derive it very easily since P equals M multiplied by V. Mass is measured in kilograms, okay, and velocity is measured in SI units as meters per second. So the units of momentum will therefore be something a little weird, kg meter per second. Okay,
Is
so
that a dot for multiplication?
yeah, I added the dot for multiplication,
Okay.
kilogram meters per second. So you can now say that the train's momentum was 40,000 kg meter per second, and this one, the scooter's momentum is 100 kg meter per second.
Hmm.
Okay, so the units for momentum is something a little weird, kg meters per second. It is what is known as a derived unit, but it will make sense once we understand how does larger momentum produce larger force upon impact. Okay, so that is the next part that we are going to look at. Also, talking a little bit about one more situation which is also interesting to think about. When a bullet is fired from a gun, okay, so I'll try to draw a gun. Okay, a very rudimentary kind of a gun, something. Okay, and a bullet is fired from this gun. So we understand now how that works. There is some kind of a chemical which is stored in the bullet, and there is a hammer that hits the chemical explodes. There are expanding gases. The gases expand very quickly, so there is a force that is applied on the gun in the backward direction. We call that the recoil force, and the reaction force to that is the force that is applied on the bullet. So there is a bullet inside this, and that bullet will now accelerate forward. Okay, so this bullet, which comes out of the gun at a very high speed, it can be moving at something like about 300 meters per second. Okay, and the mass of the bullet can be something like about 100 grams. So the question can be asked, in the case of the bullet that is coming out of a gun, there is considerable amount of force that is applied when it impacts. So let's say it hits some kind of a target, right? It has an enormous amount, it applies an enormous amount of force on that object. If it were something like a living being, then the force is sufficient to sometimes pass through the body. So it enters with an entry wound, passes through the flesh, and exits on the other side. It carries so much force upon impact. I mean, it produces so much force upon impact. So what is the momentum for this bullet? Okay. Will you be able to calculate that and tell me? Remember, this is in SI, but this is not in SI, so you have to convert it. Okay, and if you do that, you will find something surprising. So I'm waiting for somebody to do the calculation and send your answers through the chat.